This is Team Gary coming at you live with Science in the AM, grade 9 science. Yesterday, we wrote down a few things, watched a little video. High voltage is like high pressure in a water flow. Causes a high flow rate. Low pressure results in lower flow rate. Voltage is like the elevator that lifts the electrons to higher energy. We jotted this fact down and this analogy. And the other thing we jotted down was the greater the current through the light bulb, the brighter it seems to flow, or the brighter it glows. Talked a little bit about resistance yesterday, but right now what we're doing is measuring voltage. We are using voltmeters, and I'm going to just, they're multimeters, but right now we're using it as a volt. They're ammeters, they measure amps, and you can figure out some stuff about resistance. Now, we have a battery and a bulb, and we knew how to do this. Now we've attached a cross to measure the drop in energy of each electron as it goes through the light bulb. That's what we're measuring. And I have one surprising group there, and I'm going to actually switch out the battery and just see if it's your meter or something, because the battery shouldn't. Anyways, it exceeds what it should have been brand new. So we'll see. Anyways. You're going to write down this diagram, and then volts equals, you're going to write down your 1.25 was very common. And it depended on your battery. Because they're kind of old. They get drained of energy. I'm going to pause the video. If you're at home, jot this down and you can continue it. So right now, this is what we've written down. 1.2 or 1.25 volts. It's usually around it. That's expected. Okay? We've measured how much energy is lost when the electrons zip through the light. That's essentially then how high this boosts up. It's like lifting an object 1.25 meters above the floor and then dropping. You measure. Now, I'm saying 1.25 meters, which isn't an energy unit, but it's understood that you get higher energy as you get higher. Okay? How much does the energy drop? That's, we sometimes call this potential drop. And it's but make sure you have a V behind this, okay? That's the unit. Like centimeters is the unit you might use to measure a line. Okay? We call it potential drop in physics, but most people just call it the volts. They call it the unit. So if you say the kilometers, it's a travel. Now, what could we do with this circuit? One light bulb to see what happens if we had a second battery. What do you think we put a second battery in? What do you think happens to the volts? We go up, down, stay the same. Second battery? Up, yeah, okay. How could we attach a second battery in this system? Stack one on top of the other. So we're going to take a second battery and then go like this and now move the wire to the bottom, right? I guess but that's the idea. And now move the wire like that, right? So we need second batteries. I'm going to pause the video while we try that out. See if it really, but that's cool. Okay, we've stacked this. I'm going to get you to do a second diagram. I'm just going to readjust my diagram. And we'll put down what we're doing this time. So I think you know how to do the diagram, but I'll just show it to you. Okay, this time, I'm going to get rid of one. There we go. This time, I've got two batteries stacked, right? Voltmeter, as expected, we put two batteries in there and kind of doubled. You got 2.4, 2.5-ish, something like that, right? Okay, so you can imagine if you had a third battery, what would happen? Okay, we're going to write this down. I'm going to put 2.5. Okay, if you got Also, though, people noted that the light bulb was bright. And yes, I was going to just extend this here. Also, brighter light with two bulbs. Two batteries. Okay, you guys do that? I just remembered something I have to enter here. So what if we tried two batteries but hitched up different ways, what we're just asking? We got a word for the ways we're hitching this up. So what if I take, I'm going to just erase this one, and I'll get a small piece of copper wire. And I attach, boom, to that, and then hitch it up to the battery. You guys follow what I'm saying? I'm going to have to give you guys some wire to do this. Okay. Different way of hitching it up. Okay, let's see what happens. Okay, now to edit this diagram for two batteries side by side is what we're going to say right now. I'm going to change this back. It's the same voltage as if it was one battery hitched up this way. Does this do anything at all to the circuit? Well, we're going to figure out 1.3, 1.25. Okay. Now, and the brightness was about the same. Would you guys agree? Okay. One way is called hitching up the batteries in series. One is called hitching up the batteries in parallel. There's advantages to both, depending on what you want to have. Talk to you later about that. I'm going to pause the video. This is what we've got so far. I'll measure. Okay. People have this down. I'm just waiting. Okay, well, then, time to get it down. Now we're going to try measuring current. One bulb at a time first, or one battery at a time. Draw this first, and we're going to switch channels on it to make it an ammeter. We'll talk about that in a second. We'll see if our ammeters are actually working for the amount of battery juice we have. So with the blue, just to explain this diagram, we understand the battery and the bulb. The blue would be the alligator clips that we're using, alligator clip. And then the ammeter needles, that's the black and, is this orange or something? I'm colorblind. Red? Okay. Black and the red. And that makes sense because those are black and red. We're going to see if our ammeter channels work for this. I'm going to stop recording for a second. Let's see what we get. Okay, everybody's just cleaning up. We got the amps reading, but they're exceeding the 500 milliamps in most cases. Some are 400 amps. But it is working. We'll see. That's enough. Have a great weekend.